Hi everyone, in this video I'll introduce you about speech emotion recognition. Recently I have uploaded a code to my GitHub repo, and this code you can just copy and paste and run it directly on the Google Colab. And to use Google Colab, all you need is your Google account. And once you have Google account, then you can go to the drive. Then you can create a folder. Let's say new folder and speech emotion recognition SER create, and double click, and by right click on your mouse, then you can see Google Collaborate. And if you don't have it installed, then you can go to this here and you can type collab and you can install it from here. So as I have already installed collab, by right click on your mouse and go to Google Collaborate, click this, then it's gonna create Jupyter notebook for you. And let's go from um, here. So for speech emotion recognition, you need training data, and for training data, we'll use Robdex dataset. And Robdex dataset, you can type in Google search bar Robdex dataset and go to here. And if you go down, you can see um, videos, the actor wise, and you can see speech, video speech actor, video speech actor 02, and I'll download video speech actor 06, and it's downloading. And while we are waiting for it to be downloaded, let's go back to our Google Colab notebook, and by going to Drive, you can upload the data to my drive, and I've got already my Robdex dataset uploaded here. So by double clicking, I have actor from 1 from to actor 5, and by going back to Jupyter Notebook, and let's to connect, you can use mount. So if you go to my GitHub repo, then you can copy this and paste here. So from google.colab, you can import the drive, and if you mount drive.mount content drive, and you type shift plus enter, then it's gonna execute this block. Wait a sec. Connect to Google Drive. Yes. Hello. Yeah, you can fetch the data from your drive, and going back, import OS and import warnings here and paste. So it's gonna remove some warnings while you are using Librosa API. So again, back here, and from this whole code, what I'm going to explain is only the pre-processing part, how you pre-process the raw audio data to feed them to your deep learning model so that the deep learning model learns the features further corresponding to recognize the corresponding emotion of the given video. And for that, what you need to do is that you first need to load the video. So that is to convert the analog data to digital data. So um, let's go from how to load the video. So you need to designate the path. So let's go back to colab and you click here and sections. Actually, this one, you click this, and if you click drive and my drive and the click Lavadesk folder, then let's click this, and to copy the path, you can click here and copy path, and you can paste video path, paste. So you convert this video file to um, the digital format. So that is, we are gonna load um, so to load you need LibreOffice API. So if you go up here, you can see LibreOffice load. So copy this part and come back here. So raw audio LibreOffice download. So this is video path, and the sampling rate is 22,050, and the duration is 3. So we are gonna convert the analog signal for duration 3 seconds. And this is the sampling rate. So sampling rate, it determines how many cycles you are going to take per 1 second as the signal is continuous. And to use LibreOffice, you need to import LibreOffice, and let's look at the shape of raw audio shape. And so going back to the original code, so what it does is that it returns the raw audio and the sample rate, and raw audio and sample rate, you need 2 variables. So delete this and raw audio shape and run from here again. So you can see 66,150 dimensions, and the reason is that because the sampling rate is 22,050. So go to calculator and 22, the 1 second is segmented into 22,050 parts. So because the duration looking back is 3. So if you times 22,050 times 3, then you get 66,150. So here are 66 1050 segments of the signal. So you are going to take this raw audio and to analyze the features. Usually in signal processing, we use Fourier transform, and when you do when you treat physiological data, mostly Fourier transform is enough. But in speech emotion recognition, you need extra pre-processing, that is metaceptual frequency coefficient MFCCS. And the reason is that the range of um, frequency that human can hear is limited, so they introduced another unit called pitch. Then this MFCCS is the features that is analyzed according to the pitch unit. So um, what we need to do next is that we need to extract the MFCCS features from this raw audio to feed the training data, to feed the pre-processed signal features to the deep learning model. So going back here, and we can see MFCCS, copy this and come back here, paste mfccs librosa.feature.mfccs, and you pass raw audio argument to this y parameter, and sampling rate same, and number of mfccs we will pass 13, and then let's check the chip. So it's 13 by 130. So let's go back, and we will take all the audios and transform them into MFCC features, and then we'll map these features to the labels, and we'll pass to our deep learning model. And for the deep learning model, I have used convolution operation, 1D convolution, and going up, let's see in more detail what we are doing here. So so we need to look. So let's remove. Before we remove, let's go down here. And what I'm gonna do is that I'm going to assign loop path to the Loveless folder, as it contains all the videos of each actor. And this one, click here and copy path and paste. And this data, if you want to upload, if you go to Google Drive, My Drive, then you can just drag the folder to the specific position. For example, I have this latex .html file. Then if you want to upload this to Google Drive, and you can just drag this to this My Drive. So, or if you have a folder, then you have some files, then you can upload your whole folder, like this uh, file. Yep, drop like this, then it's gonna upload your whole folder and the contents within the folder. So let's resume from where we stopped. Go back here and root path, and then we need to get these file names. So for this, import OS, and if you actors OS the list directory root path, let's print out the actors, and we have actor 01, actor 02, actor 03, and we're going to explore, search each actor folder. So what we'll do is that for actor, in actors, you print actor, yep, here's the spelling mistake, and you can see actor 01, 02, 04, 05, and let's get full path is os the path.join, and you need to join root path. If you go up, as you can see, this is the root path, and root path and actor, and if you print full path, see, you can see the full path of each actor folder, and we'll search all these folders to get the file path. So what we can do is that for each for full actor, let's call this actor folder, and for actor folders, and for actor folder, in actor folders, full video path os the path that join root path, comma for each actor, let's actor, and actually before this, let's comment this. File names, where's the list directory, actor, folder. Let's print file names. Where's the list directory, actor, folder. Oh, I'm not sure what's going wrong, and I'll type actor folder again. So actor full. Let's go back again from let's type actor folders. Uh, so to get each folder name, let's splits with the past split actor folders. With actor per actor folder in actor folders, print actor folder. Uh, Instead of going like this, let's keep actor 1 and actor 2, actor 3, actor. Let's try up to actor 3. And for each actor in actors, print actor and pass you can get is west.pass.join folder actor folder pass actor folder root pass comma actor and actor folder. Then you get this path for each actor folder, and let's get file names with the list directory actor folder, print file names. Then you can see the file name is printed. So this is the list of file names within the first actor folder. So let's get for each file for fn in file names, and the full path will be with the path.join root path comma actor comma fn and print full path. So we get the full path for each video for each actor. And as you have seen earlier, what we need to do is that we need to convert the analog signal from the video to audio. So copy this and let's go down. So now raw audio sample rate reverse load, and what I'll do is that you pass full pass with duration 3 and sampling rate 22,050. Print raw audio a shape. There are too many, and now what we'll do is that let's create a list that will hold all these features, and we need labels as well. So let's do features that append raw, not raw audio. What we need to is that we need to convert it to MFCC features. So we need this function, copy this, and going down, paste, mfcc libros.feature.mfcc, y is raw audio, comma, sampling rate 22,050, number of mfccs, and features dot append mfccs. I want to stop this. Let's copy this and paste up here, and let's remove this and shift enter, and let's check the length of features, print length features. Actually it's taking a bit of time. It's taking a bit of time. So actually, due to the time sake, let's remove actor O2 and O3, and I'll just show you demonstration with actor O1. And copy this, and down here, copy here, remove, and run again, length, mf length features. Actually, apologize that it takes too long. So rather than showing, yeah, it's finished. It's 120, and actually, so there's for within in one actor there are 120 videos, but we need only 60, because if you go to the site, the official site of Roughness Dataset, then you can see here the first is modality and the second designates focal channel. And if you see emotional intensity, statement, repetition, and actor, and as you can see, modality O1 is full audio video and O2 is video only. And what we need is only full audio video, not video only or audio only. And going back, and if you split full path, full split, let's comment this for now. Splits os.split, not os.split full path.split, os.path.separator. So it's gonna split this full path string to according to the separator, which is backslash. Then let's print split. So as you can see here, the last index is the file name. So we'll get file name, video. Let's say video name. Let's name it video name is splits, and to get the element at last index, you can use -1 index. And if you print video name, remove this. It's printing only the video names. And going on, this one designates the modality, and the second one, if you see the original website, it's vocal channel, and the third one is the emotion. O1 corresponds to the neutral, O2 is the calm. So we'll use this as our emotion. So only for dots that is video and audio fully. So split video from video name, we're gonna split video name split video name split. We will split according to this dash and print. Remove this video name split. Then the first index is modality, so go up, and the third one emotion, and as you know, index starts from 0, so modality video name split O, and emotion is video name split 2. And let's go up, and what we'll do is that we've got already labels list. So what we'll do is that labels that append emotion, and we'll add this the rest of the features only when the modality is audio video fully. So if modality equals O1, then you get the emotion, and you append it to emotion labels, and you get the features, MF features. So going down, remove this and run again, and let's see length features and length labels. Let's wait a bit. So you'll get 60-60. So you get 60-60. And to next step is to feed these two data to the deep learning model. And to feed it to deep learning model, you need to convert this list to NumPy array. So going back, as you can see, I have converted it to NumPy array by np.asArray. So you can directly see the result. So you can just copy the rest of them. Let's let's remove all of them. Let's remove, and I'll just um, show you it running. And before you run it, you need to use the GPU. So you click this runtime and change the runtime type. And here, hardware accelerator, you type GPU type T4. ABAC is a good one, but here we can only use T4 and save. And let's go back to the code. Copy this. Okay. Paste. Copy. Paste. Copy. Paste. Um, let's change this root path to here. I think um, it is not mounted, so we need to rerun this. Hello. And now you can, once it's mounted, folder with the drive should pop up here. Yep, this one popped up. So now the rest of the following code should work. Now it's run and run again, and copy this one again. Run, copy, paste, copy, paste, copy, paste, copy, and paste. So while we are waiting, the folder is already downloaded, finished, and let's extract this. So within this folder, we can get actor 06, and let's look at one of the video. So as I mentioned, O1 is the third number, designates indicates the emotion. So if you go to here, number O1 is neutral. So let's look at the neutral emotion. Um, and more sound, and let's try let's see how angry emotion looks like O5. And going down, this one is angry emotion. Mm, yeah, she looks angry. So if you want to add this add data more onto your drive, then you can go to your drive. Uh, Actually, it's gonna take more than 3 minutes, so it's um, I think I have to skip. So I'm sorry that I couldn't show you the demonstration, but you can actually run by yourself, and I'll just finish by showing you how you can add more data. So going back to um, maybe my drive, then grab this folder. Then if you just um, press this and drag here, then it's gonna unload the folder. So looking at the code, it's still running, and let's check runtime. Shouldn't take this long actually. Um, it's taking quite long. So anyhow, the accuracy may be a bit low, around 40%, and the reason is that due to the small number of training data, and if you add more data, then it may its accuracy may improve. Or currently, the model is very simple. So actually, to show good performance, the model needs to be tuned, fine-tuned, and you can go further that to improve your model. So up to here, I have introduced about speech emotion recognition, and I'll finish off here. Thanks for listening. Goodbye.